Let's code number 1046. Last stone weight. This is easy question. Let's get into it. We have a collection of stones. Each stone has a positive integer weight. Each time we choose to harvest the stone and smash them together. Suppose the stone have weight x and y with x less equal than y. The result of this smash is if x equals y, both stones are totally destroyed. If x is not same as y, the stone of weight x is totally destroyed, and the stone of weight y has new weight y minus x. At the end, there is at most one stone left. Return the weight of the stone or 0 if there are no stone left. Let's check example 1. Okay, we pop two biggest number 8 and 7, 8, 7. So smash it and then left 1 and then put 1 again. Next 4 and 2, so smash it and then left 2. Now 2 and 1 smash and then left 1. And then 1 and 1 smash and left 0. So last item is 1. Does it make sense? Okay. Now I'm gonna tell you how we can able to reach optimal approach from the beginning. So my strategy, I will use approach with fastest time complex first. That means if I saw it, in this case, we needed to get big number first. That means we needed to use sorting. But sorting is very expensive. So I try to use cheapest first, because fastest first. One of fastest approach is heap. So first I will try to use the heap of this question. If it failed, so next is I will try to use binary search, because that also log n time complexity. But if not, I will try to use divide and conquer, but that also not succeed. I will use linear and then failed, sort, fail, or loop in loop, fail. At that time, I will try to use the dynamic programming. I'm gonna use same strategy to this question. So first, I will try heap. Fortunately, we can able to use heap. So first, we put the heap, and then when it pop, heap pop, then that must be, we can use the big number first. And then next heap pop is the next big number. And then smash it, and then there are some one left, and then put it again. Then pop, and then the next biggest numbers we can get the next biggest number. But one issue of Python only support min heap. But don't worry, we just multiply -1 each item of list. Then 8 to change in -8, and then biggest number change it to smallest number. But please remember, after finish it, don't forget to multiply -1 again to reset. Okay. Let's start code. First, we needed to change item of stone to negative, so I will use index, because we need to update the stone list. Length stones. So stones index multiplied -1. Now all value has negative value, so okay, let's heapify. I will use heap q heapify stones. Now stones to make the heap, change it to heap. So I will smash until stone is bigger than 1. Then I will make a new stone. New stone is the smash. First the stone is heap q, heap pop stones, and then next the biggest number is this one. And then I will smash it. If 2 stone is same, stone must be 0. So if the stone is 0, it's okay. But this one is above the 0, we will put the stone into heap. If stone is not 0, and I will heap q, heap push stone to stones, stone, and then I will return. Please don't forget the negative stones, 0 into, because now we have only 1 stone. And if length of stones not 0, else we return 0 because there are no stone. Looks good. In this case, time complexity is linear time. This one also linear time. This one also linear time. So it takes linear time with constant space if we do not count stone. But if we count a stone as heap, because we receive the stone as list and then we convert list to heap. So if interviewer want to consider it to calculate space complexity, we can say linear space. But normally I think that is constant. Thank you.